Okay, so in this one, we're going to cover the key types of enzymes in biochemistry, their functions, and some examples I'll give you as well. So it's going to be super useful, so watch to the end. So there are exactly 6 key enzymes, I would say, in biochemistry that you really want to know and get your head around. Many people will actually find them quite difficult and hard to remember. So I'm going to let you know them right now. So let's start with number 1, and that's going to be oxidoreductases. Quite a mouthful, that word, but let's get into it. So oxidoreductases basically are responsible for the addition or removal of H+. We can say these are addition of protons or H+, either way it's the same. And an example of this could be oxidase, and you're definitely going to see this enzyme crop up here and there in biochemistry. So that is number 1, and now we'll move on to number 2. So number 2 is going to be transferases. Now this one is super important, so you've got to pay attention here. So transferases are responsible for transferring functional groups, such as a phosphate group. And when I say transfer groups, I mean the addition. So we're adding a group from one place to another on an enzyme. So an example of this would be kinase. Now kinase is super important in many different parts of biochemistry, so you do need to know this one super well. So I'm actually going to draw a diagram here to hopefully explain this a little bit more better, a bit more clearly. So say we have an enzyme here attached to nothing, essentially, and we can say another enzyme here, which is going to have a phosphate group. So this essentially is what the kinase does. So it adds the phosphate group onto an enzyme. And as you can see where I've put active and inactive, without the phosphate group, the enzyme's active, and with the phosphate group, it inactivates the enzyme. So therefore, we can say this regulates the metabolic pathways. So this is really key later on in the enzymes topic, so do bear that in mind. Now we're going to quickly move on to number 3. So this is going to be hydrolases. Now hydrolases are also basically the opposite of kinase, and also super important. So what these do is essentially remove functional groups such as phosphate. So we can say an example of this is going to be phosphatase. Quite an easy one to remember as it's removing phosphate. And again, like with the last one, I'll draw a diagram here. And we can say that the phosphate group is being removed from the enzyme by phosphatase. And obviously previously we have an inactive enzyme with the phosphate group, and it's now active now this phosphate group has been removed. So this is also a regulation of metabolic pathways, which is very key in the enzymes topics. So let's move on now to number 4. So number 4 is going to be lyases enzyme, and these are basically responsible for forming double bonds, and this often happens by breaking the carbon-carbon bonds. And this basically also gives out carbon dioxide during this process. And now an example of this would be decarboxylase, and it sounds about right because we're removing carbon. So number 5 we're going to go move on to is isomerases. Now isomerases transfer groups within molecules in order to yield an isomeric form. So the clue is there, isomerase, and we're yielding an isomeric form. An example of this can be glucose isomerase. And if you want to look this up, how this works, you can do, but it's very simple. Okay, so let's move on now to number 6. This is the last and final enzyme on my list. This is going to be ligases, and essentially this is the opposite of what we saw with lyases. Now, ligases are responsible for forming CC bonds using ATP, which means it does require energy. That is a key point to remember here. An example of this one would be a carboxylase enzyme. So hopefully you've enjoyed that, and it makes it super simple. Thank you.